Well, the good news is that if the world does end in December 2032, you don't have to worry about buying Christmas presents that year. So, silver linings and all that. Hi, I'm Mike Siegel. I'm an astrophysicist. I write for Ordinary Times, and this is The Throughput. So you may have heard a little bit about this asteroid 2024 YR4, which is projected to have about a 1 to 2% chance of hitting the Earth on December 22nd, 2032. So what's the deal with this? Asteroid 2024 YR4, 2024 is the year it was found. YR4 is a designation for what time of the year it was found, was identified by the Asteroid Terrestrial Impact Last Alert System, or ATLAS, telescope in December of last year. It had just passed within about 1 million miles of the Earth, so it came on us by a kind of surprise. It's about a 100-meter wide asteroid that is on a very elliptical orbit that carries it into the asteroid belt and then down inside the orbit of the Earth about once every 4 years. Now, when they projected its orbit, it showed a possible impact in 2032. So why don't we know for certain? Well, because we don't know the orbit for certain. We've only known about the existence of this asteroid for a little over a month, and we've been tracking it through that time. When we first detect it, you see it on a telescope, and then it moves a little bit, and so you can calculate the orbit, and then it moves a little bit, and you can calculate the orbit again. Each measurement gets you more and more precise. So in terms of its impact on the potential impact on the Earth, if you project it into the future, those uncertainties in its orbit grow and grow and grow. So we can predict pretty close to where it's going to be a month from now, kind of close a year from now, but as time goes on, the area that it could be in grows larger and larger and larger over time. Those errors in our ability to measure it propagate into larger errors in the future. And when we do this calculation, we get basically a big area that the asteroid might be in on December 22nd, 2032. And the Earth is in that area and occupies about 2% of that area. And so we calculate, all right, about a 2% chance of it hitting the Earth. It's a little more complicated than that, but I'm giving you sort of a basic overview of what's being done. As time goes on, we will know the orbit more precisely. Right now, telescopes all over the world are observing this asteroid and trying to get more precise data on its orbit around the sun so that we can get a better projection of where it's going to be. And so you may have heard this week someone said the chance is slightly increased from 1.7 to 2.3%. That's a distinction without meaning. It means that we've gotten a little bit better, but we haven't really learned that much because these things are difficult to predict. But we should get better data. One of the previous scares we had on this was asteroid 2004 Apophis, I'm not sure how that's pronounced, which was discovered in 2004 and showed a potential impact with the Earth in the 2030s. This is an even larger asteroid, and so it was even potential more dangerous. Now, as time went on, we got better measurements, and it looks like it's very unlikely to hit us anytime in the near future. With Apophis, we had what we call a gravitational keyhole. This doesn't apply to YR4, but some of the asteroids we talk about what we call a gravitational keyhole. If this is the Earth, when an asteroid passes the Earth's gravity deflects a little bit. If the asteroid passes too close, it's going to deflect it a lot, and then on next orbit, it will miss the Earth by a great deal. If it's a little too far away, the Earth's gravity isn't going to deflect it enough, and on a future orbit, it will miss us equally. There's a narrow window where the Earth's gravity deflects it just enough to put it on a trajectory to hit the Earth. And so that's what we call the keyhole, the gravitational keyhole. That if it hits this keyhole, then it's much more likely to hit us. If it misses that keyhole, it's much less likely to hit us. This doesn't apply to YR4, but does apply to a lot of these asteroids that we do find that are potential Earth impactors. And so that's one of the things that we look for when we're trying to predict the future. And one of the reasons that predicting the future is difficult. YR4 is about a 100-meter wide asteroid. It seems to be more of an iron-nickel asteroid. So this does make it potentially dangerous. It could hit the Earth with the impact of the Tunguska impactor about a century ago that leveled forests all over Siberia and created a shock wave that circled the Earth twice. If this were to hit a city, it would hit with a power of about 1,000 megaton bomb, which is bigger than any bomb we've ever built. And so you'd be talking about complete destruction of a city if it hit a region, like say exploded over Central Europe or something like that. You could be talking about immense devastation, not species killing, but certainly something that would be quite devastating. If it impacted the oceans, you would be potentially talking about a massive tsunami. Let's say it hit in the Indian Ocean, you would be talking about a tsunami that would hit the Indian subcontinent, the coast of Africa, Australia, and so forth. You could be talking about, when you think of the Christmas tsunami that hit Indonesia many years ago, you'd be talking about something 1,000 times as devastating. That's the bad news. The good news is we're in a position now to do something about it. I see this not as something to be alarmed about, but something to be encouraged about, because this asteroid has always been out there. It's always, if it has our name on it, it has had our name on it for hundreds of thousands of years. And something good happened. We found it. We found it 8 years in advance of when it's a potential danger. So let's say we measure it and it is a potential danger. We have 8 years now to do something about it. Now, I've made videos before, Don't Look Up and Armageddon, about how we might deal with an asteroid impact. We've talked about the DART mission, which hit an asteroid and redirected it in an orbit around another asteroid. And this was a successful mission. We now are in a position where we can actually do something about it. We have the technology. We have rockets that can go up. We have guidance systems that can bring us into a collision. And the good thing is you don't really have to hit it that hard. Earth looks big to us, but in the universe, it's a very small target. The trajectory that this asteroid would have to be on to hit us is very narrow indeed. If you just nudge it a little bit, especially if you do it years in advance, it will miss us by a wide margin. And so you do want to actually do this carefully. You don't want to cowboy it. You don't want to dodge a collision in 2032 and then set up a collision in 2070 or something like that. You do want to do this very, very carefully. But the good news is we have the time. And so I've talked for years in public talks on this channel and other places about planetary defense, being able to prevent a catastrophe of an asteroid hitting the Earth. And this I see as a real life in action of it. The Atlas telescope system is designed for this. It is designed to find these threatening asteroids. We tested the DART mission. We know we can do this now. And with SpaceX and others developing ever cheaper technologies for heavy lifters to put things up into space, we don't have one shot at it. We have multiple chances to intercept this thing and deflect it off course. If it is going to hit us, which 98% chance it's not going to, but because the effects of the impact would be so devastating, you're taking it seriously. And so it's only every maybe once a decade, once every few years that we get something like this. And so astronomers get very excited and the press gets very excited because it's a rare event and a potentially catastrophic event. So I would not lose any sleep over it. 98% chance it's going to be fine. But even if you wake up one day and they say 100% chance it's going to hit the Earth, we're not defenseless. We can do something about it. Deflecting an asteroid, not getting off course, protecting ourselves, protecting our people, protecting our cities, protecting our species. This is not the realm of science fiction anymore. It's the realm of science fact. We're about in as good position as we could ever be to deal with something like this. So that's my little rant for today on real life science. We'll see you again in a few weeks for some more stuff. In the meantime, I'm Mike Siegel. I write for Ordinary Times. Thank you for watching.